In this tutorial, we will create a CNN model using transfer learning. I'll walk you through the code, and I'm not going to write the code during the video because then the video length will become very long. It might become 45 to 50 minutes. So to save time, I'll walk you through the code line by line, and I'll also share this Jupyter notebook, the code with you, and also the dataset. You can find the link in the description below. We will use MobileNet architecture and its weights trained on ImageNet dataset. By using a model with pre-trained weights and then training it on a new dataset, we can reduce the training time required to fit the model to the new data because it had already been trained on thousands of ImageNet dataset. Weights are fine-tuned for the deeper, fully collected layers, and rest of the shallow layers are left as it is. Transfer learning is the improvement of learning a new task through the transfer of knowledge from a related task that has already been learned. So here we are going to use the concept of transfer learning, and we will use the MobileNet architecture. Now what we are doing here is, first we are importing the necessary libraries that we need. So we are importing here TensorFlow, NumPy, OS, then Matplotlib. Now in the next line we are defining a function. So this is a function, and this function is to read our data set. So this function will take the file path and then it will start reading our data set. So this function is nothing but just to read the data set. Now if you come in the next line, so here you will see that we are using this same function, cats versus dogs annotations. Here you can see. Now what we are doing here is we are using this function to read our data set, and the data set is saved in this folder annotations, and there are two types of data sets. You can see here we have this train and test. So you can see here we are creating two variables, train annotations, and then the count of this training data set, that is how many examples are present in our data set. And then we are doing similar for the test. We have this annotation, and then we are counting how many samples or examples are there in this test data sets. And you will see here we are writing an annotation. So annotations are nothing but they have keys for various image file names, and the value is class for that image file. So I'll open this annotations folder and I'll explain you what this annotation stands for. So if I go to my folder here, so here you will see I have these two folders, annotations and images. And if I open this annotations, so we are using two files, that is test and train val, and I'll show you that. So here you can see we are using these two files, train val and this test, and both are text file. And let me open one of these. Let's say I'll open this test file. So this is a text file, and now here you will see what we are seeing here. This is the key. You will see here what it is a key, and then what we are seeing here is the class. So we have a binary class here, 1 and 0. That is why we are getting this annotations here, and then we are getting the class here. And I'll close this one. You can also see here we have these names here, and then we have this class. So these are annotations. And if I go back, the images of cats and dogs are present in this folder. So you can see we have various images. So if I open one of the image, let's say this one, so we have this of class cat. Then similarly we will also have for dogs also. And so here you can see we have image for dog here, and here also you will see we have images for dog. So these are the images of cats and dog. And one thing you might have noticed here, that in this annotations, if I open one of the annotations, so here this belongs to class 1. And if I scroll down, you will see here we also have this class. You are seeing here 11, 12 and so on, because the original data set or the original model that was trained on the MobileNet architecture, that model had 1000 classes. So that is why you are seeing some more classes here, but we are going to work on a binary classification, and we will use only two images that we have seen, that is one for cat and the other for dog. So that is why this is going to be a binary classification, but the original one, the model on which the data was trained, the ImageNet dataset, there it had 1000 class. So in this line what we are doing is we are just importing this annotations from this train and here from the test, and then we are just getting the count. And what we have seen is, so these are the, you can see we have this JPG images, or the file name. You can see here I am printing one of these train annotations here, and you can see it is displaying here. This is a JPG image and the category is class. And if I scroll down, so you will see we also have this for dog also. And then similarly for the test here, and then we are just getting the count how many images are in train and test dataset. So in train you can see that we are having more than 3680 images, and in test we are having around 3669. Now here in this next line what we are doing is we are creating two dictionaries. So this is class to index. So now what we are doing here is we are defining that if the class is cat, then the label is 0, and if the class is dog, then the label is 1. And now here we are just reversing it, index to class. So if the class is 0, then the label is cat, and if the class is 1, then the label is dog. That's it. So we are just defining that. Here we are creating a function random batch, and about this we are defining the path of our images. So our images are in this path, which is images folder. So I've already shown you, we have this images folder, you can see here. So all the images are stored in this folder, and that is what we are defining here. Then we are creating a function random batch that will take annotations, and it will return a randomly selected image from our train or test data set. So we are passing these two parameters here, and annotations and the batch size. Batch size is the number of images that we want to see. This function will also help us in training our model, because at the time of training we can select random examples to train our model using this function. Now this function takes annotation dictionary and batch size. So you can see here we have this annotation and then batch size here. And now what we are doing is, then in the next line we are just getting the list of all the keys and storing in this variable all keys. And then to get the total number of examples, we are just getting the length of this all keys, and we are saving in this variable total underscore examples. And now in this next line we are using this function np.random.choice, because we want to make sure that we want to select random examples. That is why we are using this functions random.choice. This is not 100% correct that you will get random images, but it always try its best that it will get the random images, not the repeated images. And then we are just passing the batch size. Now here we are defining the x and y. So in x we are passing the batch size, and then this we have this image size here 128 by 128. So this is nothing but the image size. This is the shape of our image, and the MobileNet architecture and weights support this size of images. There are 2-3 more different sizes of images which is supported by the MobileNet architecture, and this is one of the size, that is 128 by 128 by 3. And now here in y, so this is a you can say this is a x variables, and this is our y, this that is the target variable. And here batch size, we are defining the batch size and one because this is a binary problem or a binary classification problem where we have two classes, cats and dogs, and that is why we are defining here as 1. And now in the next step what we are doing is we are pre-processing our images. So from Keras we are loading this pre-processing and then image, and then we are giving us the path of the images, and then our target size is similar as what we see here, 128 by 128, and then we are appending these images to this image list. So we created here an empty list of images. So once we are done with the pre-processing, we are appending the images to this image list here, and then we are again doing the pre-processing on this image. So here you can see we are calling this image here, and we are doing some kind of pre-processing here. And then in the next line, so here you will see we are using this simple TensorFlow.keras as pre-processing, and after that now we are using the pre-processing from this MobileNet architecture that we are using as a transfer learning here. Now once that pre-processing is done, then we are just expanding the dimensions of the images, and then we are saving in this variable array. And then to get the class of the images, we are using this class to index, and then we are passing the dictionary here. So we have already defined this above class to index, and if I go up, you can see here we have this class to index. So this will give us whether the class is 0 or 1, and then in the end we are just returning this x and y and the images that we have saved. So once this random batch function is defined, which will give us some random images, then now the next thing is that we want to display those examples. So what we are doing here is we are again creating a new function, display examples. So this will help us to display examples and nothing more in this. So we are just calling this x, y, p images and index to class these parameter, and then what we are doing is we are just loading the images. So if in the next line you will see, this is a very simple function. Now in the next line what we are doing is now we are getting the random images. So we are using this function random batch here, and inside this function we are passing two parameter. The first one is the annotation dictionary, and the second one is batch size. Now in this we will pass the annotation dictionary, and batch size I am passing it as 10. That means I want to see 10 images. Now once I have the images in this x and y, now I'm using this function display underscore examples, which we defined above. Here you will see display examples. Now I'm calling this function display examples, and then I'm passing these parameters and the images, and then index to class, and then I'm doing this show here. So you can see we have these 10 images here. So we have images for cat and dog, and these are total we can see we are having this 8 images, not the 10 images. So we are having this 8 images here instead of 10, because here I am calling this range function, and in this I am defining only 8. So that is why even if I pass here batch size is equal to 10, this display function will give me only 8 images. If you want to display more images, then you have to change, you have to make changes in this range function. So instead of 8 you can pass here 10, then you will be able to display 10 images instead of the 8 images. Now the next thing is that once we have done all the pre-processing of our images and we have also seen our images, the next step is to create our model. And here we are creating our model. So we are using this MobileNet version 2 architecture for transfer learning. So what we are doing here is we are defining an object mnet, and then from Keras application we are calling this MobileNet version 2 architecture, and from this we are calling the class MobileNet version 2, and then we have this one parameter which is include is equal to false, and this is because the ImageNet dataset has 1000 classes, but we have a binary class that is 2 class only, cats and dogs. So we don't want to use all the layers and all the layers. That is why we are setting it as false here, and then we are giving the image shape here, which is 128 by 128 by 3, and the pooling is going to be average. It means the final convolutional layer will be converted from a 4-dimensional tensor to a 2-dimensional, so that we can we can input that in our final fully connected layer, and then we are using the weights. So weights we are using from the ImageNet dataset. We are not defining any weights here, and then we are calling this summary function. And when we print the summary function, you can see the complete architecture of the MobileNet, and this is the complete architecture, what kind of layers we are using, or what kind of layers is already present in that MobileNet architecture. So these are the layers. So we have, first is the input layer, then we have convolutional one, and then padding, here the padding is 0 padding, then convolutional 2, then batch normalization. So this is the entire architecture of the MobileNet version 2, you can see here. And if you scroll down, here you will see that we have total number of parameters, then trainable parameters and non-trainable parameters. Then in the next step, we are defining a function create model. This will help us to create our model, and inside this, first we are defining an object model, and from keras dot models we are importing the class sequential, and inside this we are calling this object mnet, which we already defined above. Here you can see we defined the mnet class, and then we are giving here dropout, which is 0.5 here. So our dropout is going to be 0.5, and then we are calling this activation function. Activation function is going to be sigmoid, and you will see that we are using here 1 because we have this binary class here. We have only 2 classes, cat and dog, that's why we are using 1 here. And then we have this model dot layers dot 0 dot trainable is equal to false. It means that we are just going to train the top layers and not the pre-trained model at all. So we are just going to train the top layers, otherwise all the we already have the trained model with us. And then we are in this next step, we are just compiling the model. We are using the loss binary cross entropy because we have this binary class problem. Optimizer is going to be Adam, and the matrix that we are using is accuracy, and then we are just returning the model. Now what we are doing here, in the next step, we are calling this function create underscore model, which we defined here, and then we are calling this model summary. So this model summary is for our model that we are creating on the images of the cats and dogs, because here we have only 2 classes, and this is the original MobileNet version 2 architecture, and this model had more than 1000 classes in the target variable. That is why you can see the architecture and the number of layers are so many layers are there, because it had 1000 classes, and our model has only 2 classes, cats and dogs. That is why we are just tweaking this pre-trained model just a little, so that we can make it a binary type of problem. That's why we are compiling the model here, and we are defining the loss as binary cross entropy. So this is the architecture of our model, and it is using, you can see here, MobileNet version 2, and this is the architecture. And then we have this dropout layer and the dense layer. Now here you will see the total number of parameters are 2259, and here if you see here, if I scroll down, so here you will see we have this total parameter 2257984, and here we have 2259265, but the trainable parameters are 1281 only. And above we were using we were using all the parameters to train our model. If I show you here, you can see we were using almost all the trainable parameters here out of the total parameters. So we have this total parameters, trainable parameters, and this non-trainable parameters. So this is nothing but the subtraction from this one. The next step is to train our model, and first we are creating a function to generate continuous data, and that's why here you will see we are taking 2 parameters, batch size and annotations. And to create continuous data, we are setting this while loop as true, and then we are getting this annotation dictionary and the batch size, and we are saving it in X and Y. And now in the next line we are defining the batch size. So batch size is going to be 32. Then we have steps per epoch. So this is like you can say mini batch gradient. So steps per epoch is nothing but what we are doing is we are getting this training annotation keys and we are dividing it by the batch size, and then we are converting it into a list, and then we are taking its length, and then we are just converting it into integer for the steps per echo. And then for the validation steps we are doing the same, and here instead of training we are taking the testing data set. Here you can see we have this steps per epoch 115 and validation steps is 114. And now in the next step we are actually fitting the model. So we are calling our model, and then we are calling this function fit underscore generator, and then inside this we are passing these parameters, that is data generator, this will that we defined above here to get continuous data here. And inside this we are defining this batch size, the training annotations, the validation dataset and the validation dataset, and then its batch size and the test annotation. Then we are defining the steps per epoch, this one, and then validation steps, this one, and epochs is going to be 1. Epochs is 1 because we are using a pre-trained model, that is transfer learning, so we just need to train it once, not 10 or 20 times. And once we do the training, so here you will see we are getting the loss. Here loss is 0.25, accuracy is 0.89. this is for the train. And then we have this validation loss on this. You will see here we have this validation is here, validation data. Here you will see validation data. So on this validation data we have loss of 0.11 and the validation accuracy is 0.96. and then we are making predictions here. So to make predictions we are calling this random batch functions, and inside this we are passing our test annotation dictionary and the batch size. And then here we are calling this predict method on this X, whatever images we are saving in X, and we are making the predictions and saving this variable pred. And now to look at the predicted images we are calling this function display examples, and then we are passing our xy and then the predicted images and the index to class. And now here in the output you will see we have these predicted images and all the images which are in green color. So you will see here dog, it is in green, cat, it is in green, dog, it is in green, it is also in green. So all the images which are in green color are correctly predicted, and here you will see in the output all these images are correctly predicted class. So these are the correct predictions, and if I print more then you will find 1 or 2 red images as well, because our accuracy is 89%, or you can say 90%. 10% of the images are misclassified. So if you print these images randomly, then you will also see some of the images which are misclassified in the red color. So this is how the transfer learning works in TensorFlow. So what we do is we actually use a pre-trained model on a new dataset which is similar to the pre-trained dataset, and then we can call its architecture and everything, and we can just fit it on the new dataset and we can get a very good results. So you can see here that we used this pre-trained model and still we got an accuracy of almost 90%, which is quite good because we did not have to do much. I mean, we did not have to try many epochs or the different parameters. Without doing all those stuffs, we got an accuracy of around 90%. So this is the benefit of using transfer learning. This tutorial was about transfer learning in TensorFlow. If you like my video, you can subscribe to my channel. Thank you for watching.